Welcome to this ATA Insights webinar. Thank you for your ongoing interest and support of our webinar program. Today's session will begin in 2 minutes. ATA Insights Webinars is an online platform for the dissemination of professional renewable energy knowledge across international borders. Our aim is to democratize access to information, for innovation to spread faster, and to make the industry more competitive. And we do this through our online sessions, open to all our members. Every year we do more than 100 sessions with over 250 speakers, 50,000 attendees from more than 50 countries. To participate in the session today, use the chat on the right-hand side to introduce yourself, your company, and where you're joining from. Under the screen, you will find the Q&A box, where you can send your questions for the speakers. We will get to as many as we can today. We're recording this session, and we will send you a link to the materials in a few days. Please consider supporting our content creation for the webinar program. Contact us on the email on screen.
Good afternoon, everybody. I'm Milena from ATA Insights, and I welcome you to our webinar on energy storage in Brazil, emerging opportunities. Today, I'm connecting from Madrid, and you can tell me through the chat from which company and place you are connecting. If you want to ask any questions to the speakers, you can put them in a Q&A box, and in the last 20 minutes, they will be answered. If you are watching through YouTube, you can send the questions to the chat, and our team will send to Zoom, so the moderator can see them. This session is being recorded, and in a few days, we'll send you all the materials used in this webinar. And now, let's meet our speakers. Pedro, would you like to tell us a little bit about yourself?
Yes, good morning, everyone. My name is Pedro. I work at Syra Solar. Syra Solar is a company that operates in the photovoltaic segment in Rio de Janeiro. We have more than 200 projects in operation here in Rio. I'm also a researcher from Universidade de São Paulo. I am affiliated to the Research Center for Greenhouse Gas Innovation. Specifically, I participate on the core for geological storage of carbon and energy innovation. And I'm currently engaged in a project for large-scale storage of energy in form of hydrogen in salt caverns. I will talk a little bit about that in the presentation as well. Okay?
Pedro. Marco, would you like to tell us a little bit about you?
Sure. So good morning or good afternoon, good night, everyone. Feel greeted in your proper time zone. I'm Marco Conte from Greener. Here in Brazil, we are the main market intelligence company regarding the PV market, and also we focus on the energy transition. Today, we'll talk a little bit about the energy storage market, our perspectives, and I'll tell you a little bit more at the end of my presentation of some of our reports and the team's work. Thank you.
Thank you, Marco. Hansen, would you like to tell us a little bit about you as well?
Oh, yeah. Thank you very much for the invitation. It's a pleasure to be here today. And I'm a researcher professor at the University of Campinas, where we develop batteries, supercapacitors, reformer for biogas, biomethane, some hydrogen production using, for example, these reforms. And we are a team here with about 100 researchers developed from the TRL 1 to 6. So we are a university that do prototypes. So that's it.
Thank you so much, Hansen. Jocelino, would you like to tell us a little bit about you as well?
Okay, thank you. Hi, everyone. It's a pleasure to be with you here. I work at Moura, Moura Batteries, for 10 years in the group. I started studying the subject of energy storage in 2012 when I was doing my master's. So we were in the first beginning of the first initiatives in Brazil of energy storage projects, R&D projects, before the call 21. And then now the market is starting. So I'll be pleased to share with you some projects that we are developing on the construction and on operation. Okay.
Thank you, Jocelino. Thank you all for all of the introduction. Pedro, whenever you're ready, would you like to start your presentation?
Yes, I will share my screen. Just a second.
Wonderful. Whenever you're ready.
Okay. Okay, everyone is seeing my screen? It's okay?
Yeah, it's all perfect.
Okay, perfect. Good morning, everyone. My presentation is about the new frontier of the Brazilian electricity sector, the energy storage, right? My presentation is focusing on business models, technologies, analysis, and I will also try to give you an overlook of how Brazilian electricity matrix is evolving, and why Brazil is now a very opportunistic market for energy storage for several different applications, okay? Here, I'm showing the profound transformation that the Brazilian electricity matrix is passing through right now. Actually, since some very recent years, I would say 5 years at most, our very recent past matrix was very well established with the market agents very well delimited. We had the generators, transmitters, distributors, and at the end of the line, the consumers, right? And right now, we have a much more complex matrix where consumers, they are acting as generators, engaged in other different activities as well. And in very few years, I believe, the next 2 or 3 years, we will see the customers doing storage as well. I believe that in the next year, for example, Brazil will develop very well its supply chain for batteries and hybrid inverters. And so it will be possible to develop the storage segment behind the meter, let's say like this. There are other changes going on. One of them is related to the climate change. Our range regimes are changing very much. It's bringing a lot of unpredictability. And it's important to not rely only on hydroelectric reservoirs for energy storage. Brazil has the potential, and it would be very important to diversify our storage market, okay? And another change that is impacting our electricity matrix is in the consumer side. Some economic segments that usually were based on fossil fuels are now passing through an electrification process. For example, electric cars. That's another segment that we believe that will grow very fast in Brazil in the next years. Okay, it's already very fast, and I believe that we will be even more in the next few years. Here, I want just to give you an outlook of our electric matrix. I'm sorry, my friend Marco from Greener, I want to go too deep in this subject, but it is important to contextualize what I will speak in the next slides. But in general terms, Brazilian matrix is based very much in renewables. Today, more than 30% of our matrix is based in intermittent generation from aeolic and solar technologies, okay? And speaking just about solar, 69% of this generation is distributed generation, what makes the grid management even more complex. for the national operator, okay? And the expectation is that this intermittent segment grows even more in the next few years. By 2028, our national operator expects that Brazil will have 2.5 times more energy offering than consume. Imagine how much surplus it represents. And what is the problem with this intermittence here in Brazil? Today, we are having a load variation intraday, in the end of the day, mostly because of the solar generation, around 30 gigawatt hour. At noon, in a period of only 3 hours, we have a load decrease of about 30 gigawatts. And today, a big part of our spinning reserve is directed to solve this variation, okay, to increase the load on the grid. And so, in one hand, we have this load variation problem. We are also relying on thermal power plants, so the price of the energy is increasing as well. So, in one hand, we have this load variation on the grid and our spinning reserves getting in full capacity to solve this problem. And in another hand, we are already facing some energy surplus in the present, and in the near future, we will have 2.5 times more energy offer than consume. So this is the perfect environment for energy storage applications, okay? Okay, going to our regulation structure. Today, Brazil don't have established regulation, but our National Electric Agency is working on this structuring since 2018, and it's expected, Brazil is expected to have a definitive regulation next year, okay? Several public consultations, resolution has been implemented in this period, but so far, we don't have a established regulation, okay? Taking this into consideration, I brought here some interesting, energy storage application that would be interesting for Brazil. I want to go through each of them because it would take too much time, but my intention here is to show how big the Brazilian energy storage market can be, and I will highlight the segments that I believe would be more interesting for our current regulation status, okay? The first one, I believe it will be very important for Brazil for the next years, seasonal storage, and mostly because due to this problem I mentioned about the hydroelectric reservoirs, price arbitrage is a very big opportunity in Brazil. We have our PLD, we have a variation, a price variation of our megawatt hour during the year, and now during the day, very high. 10 times, it varies in a proportion of 10 times during the year. So it gives a very good opportunity to make price arbitrage of energy. Load following is application that will be very important. Transmission distribution for sure. Peak demand reduction, off-grid solution will be very interesting as well. Integrating renewable energy sources as well. Backup power, and no doubtly spinning reserves, okay? So if you are interested in coming to the Brazilian market, I would focus possibly on those segments, okay? Take into consideration our current electric regulation structure and what is being studied by our National Electric Agency. as a direction for our energy storage regulation, I delimited 4 business models that I believe will be more interesting for Brazil at this moment, this status of our regulation environment, okay? The first one is storage with transmission, acting as a transmission asset, maximizing system loading with high renewable penetration, deferring new infrastructures investments. Capacity reserve as well, meeting power requirements for new or existing projects. This one here is very interesting because it's already regulated by a decree since 2021. Storage with generation, I think I don't need to go through very much on this one, right? Due to the intermittency generation of solar and eolic. Our national agency is possibly putting some demands for storage with new intermittent generation projects in the near future. And at the end, virtual power plants. And in this one here, I talk about specifically about the storage behind the meter in residential, commercial, and industrial segments. I believe that in the coming year, the next year, we will have a very good, very well-structured supply chain, and this segment might grow a lot in Brazil. And we, Syra Solar, are looking for work in the segments for the coming years, okay? In this graphic compares several storage technologies in terms of discharge duration and storage capacity, and try to engage them in some few applications that are related to those characteristics of each one of them, okay? For example, when we look for the left low side of the graphic, you can see the capacitors and superconductors with very small discharge duration and small storage capacity. And they will have some specific applications on the grid, and they are already very important, and they are used here in Brazil, okay? For medium storage, medium capacity storage, and medium duration of discharge, we have our lithium battery. It's applicable also for small storage capacity, okay? But the problem is that the cost is too high, and they are appropriate for some applications, but not all. And at the top side, the top right side of the graphic, you see the geological storage systems. I am myself engaged in those kind of applications. I will present to you in the next slides. And those systems, they are favorable for large-scale storage, mainly because the marginal energy storage cost is very low on those systems, much lower than lithium batteries and pumping hydro, for example. The hydrogen salt cavern can be 2,000 times cheaper than lithium batteries for large-scale storage, and 240 times cheaper than pumped hydro for large-scale storage, okay? This is the system that I'm engaged in the development. So basically, we use energy first, initially use energy from the grid to produce hydrogen by electrolysis. Store this hydrogen produced in the electrolysis process in salt caverns. We use the energy from the grid when the prices are low, and then we withdraw the hydrogen and convert to electricity again when the prices are high, and inject this on the grid again, okay? This technology is applicable for seasonal storage mainly, and there is a huge opportunity in Brazil for this segment. This project is being developed in Universidade of São Paulo under the Research Center for Greenhouse Gas Innovation at the core of innovation for geological carbon and energy storage. So this innovation center has several technological-based companies that are affiliated to them, dozens of researchers, experts from University of São Paulo, but also from people all around the world, partnership with very high standard universities all around the world. And we are engaged in several research related to geological storage of energy and carbon in Brazil. Thank you very much.
So much, Pedro. A reminder for everyone, we have a Q&A box just in case if you'd like to ask some questions to our speakers. I'll give the floor now to Marco. Marco, whenever you're ready.
Okay, great. Can you see my screen?
Yes, perfectly.
Okay, so thanks to Pedro for starting the discussion with this extremely exciting topic. So I will talk about a little bit about a macro perspective on the Brazilian energy storage market. So starting, we have to analyze what other applications already exist around the world. So we have some developed countries leading this way with United States, China, South Korea, Germany, with different demands, with demands for behind the meter systems, hybrid power plants, ancillary services. Each one of them have their particular needs and particular solutions that they provide in their respective markets. As you will receive Elena told me that you will receive the presentation later. I will not focus very in detail in this slide. So talking about the global capacity by 2030, we see that especially United States and China will play a main role in the development of new storage capacity. And the expectation is that by 2030, we reach more than 500 gigawatts of installed capacity and almost the triple of this in terms of energy, 1.432 gigawatt hour of global cumulative capacity forecasted for 2030. And I highlighted here this small bar, which is Latin America, and I'm going to expand on this one. So in Latin America, we're expected to reach almost 10 gigawatts of capacity, cumulative capacity installed by 2030. This will represent around 2% of the total installed capacity, and Brazil, Chile, and Mexico are expected to be the main markets here in Latin America. So, as Pedro already mentioned, there are lots of possible applications. I will group them in simpler terms for off-grid, in front of the meter, some call also after the meter, and behind the meter, which is the consumer side. So starting from the in front of the meter, we can talk about the hybrid power plants, generation plus storage. Because here in Brazil nowadays, one of the main issues is the lack of transmission networks available capacity for the power to flow from the generators to the grid, to the consumer side. This especially happens because we have a more concentrated area of intermittent generation sources, so solar and wind. We have a huge concentration of them, especially on the northeast area of Brazil, and most of the loads is concentrated to the southeast, and south region. So we would need a very robust transmission network capacity to flow the energy from this generation point to the consumer point. And nowadays, one of the main reasons for the not approval of the new large-scale solar or wind projects is especially regarding this lack of transmission capacity. And also, it would facilitate the dispatching of these highly competitive and clean sources. We also have the opportunities in transmission and distribution grid, having the storage be beneficial to optimize these investments in substations and distribution facilities. And regarding the transmission side, we already have one big project developed here in Brazil by ISA-CETEP, that's how we say in Portuguese, in the substation of Registro City. And this project is 30 megawatt of power and 60 megawatt hour of energy. This project was developed especially for the peak shaving during New Year's Eve, and it's already in place, it's already operating, and its first operation was in December 2022. I brought here what would be the load profile that ISA-CETEP was forecasting. So the forecasting would be this yellow dotted line, yellow dashed line, the total transmission capacity that the grid could possibly offer is this gray line, and here we see the discharge of this BESS, of this battery storage system. So with the implementation of this project, there was no blackout because the main risk was of a blackout due to overcharging. And also here we can see that the operation went smoothly. It started and then it ended its discharge. Also talking about the ancillary services, we can see that compared to other countries, Brazil has high rates of supply interruptions and grid oscillations, which are indicators of poor or not so great energy quality supply. But the one side back here is that the current regulatory framework, as Pedro also mentioned before, does not remunerate the use of energy storage systems for the provision of ancillary services. Talking about the other two, so when we talk about off-grid and behind the meter, we have this forecast for the Brazilian energy market, which annually is likely to exceed 1 gigawatt of powers from 2024 onwards, and a total demand until 2030 of almost 14 gigawatt hour, with commercial and industrial applications for medium voltage consumers being the main market segment for these applications behind the meter and off-grid. So here you can see how is the behavior that we expect from today up to 2030 and the segments for off-grid, low voltage, and medium voltage consumers. Specifically talking about now the off-grid market, I can mention mainly the applications for the coupling of diesel, PV, and batteries. Here I brought the example of Amajari and Pacaraima cities in the isolated systems of Roraima, in the very north part of Brazil. The expectation is to save approximately 17.5 million liters of diesel simply by coupling these diesel generators with PV and batteries. The investment in this project, adding up to 10 megawatt of capacity to supply around 30,000 residents in the area, was 50 million Brazilian reais, which in dollars at that time would be around $10 million, US dollars. And this is one of the cases for the Amazon region that today Brazil estimates that we have around 1 million people without power, without electricity supply here on these regions. And the PV plus storage solution will for sure play a main role in terms of providing energy to more people that today still don't have access to this energy, but also reducing the diesel consumption on this area, which is the Amazon rainforest area. talking about the behind the meter solutions nowadays, we sorry, we can mainly go back to the topic of reliability, where here is a graph representing the equivalent interruption duration per average per consumer unit. So here in Brazil, we have around 11 hours that each consumer here in Brazil, in average, spent without electricity last year due to some fault or due to some blackout. In the end of last year, here in São Paulo, for example, we had very heavy rainstorms here, and then lots of consumers in key areas of the city stayed without electricity supply. And here, also talking about residential, commercial, industrial applications that maybe if even a very short time of a very short period without electricity supply can cost millions, or even hospitals, for example, when we talk about lives. And to summarize these discussions, we also need to talk about the evolution of the costs. So here's the mapping of Bloomberg NAV, which shows that from 2013 up to 2023, last year, we had a significant decrease in the prices of the cell and of the pack, which is the cells together, let's say. And in the near-term outlook, Bloomberg also expects that prices will still keep going down, not so significantly, but still in a reducing trend. About Greener, I will not say that 100% of this information, but most of this information, 95%, let's say, you can find it in our reports. So specifically, this one was the information was extracted from our strategic market report of the Brazilian energy storage market. But we also have other reports for utility scale PV market, for the distributed generation market here in Brazil, and what we call remote distributed generation, which is for large scale DG, for example. Here in Brazil is quite common, and I invite you to take a look at our website and see more information about it. Thank you, Elena, ATA Insights for the space, and looking forward to hearing also the other speakers.
Thank you, Marco. It's a pleasure to have you. Hanson, would you like to share your presentation with us?
Oh, yes, of course. Let's go. Please let me know if you are seeing it.
Yes, we are.
Thank you very much for the invitation. And we are Brazilian Renewable Group. We discuss here the energy storage. We try to identify the best regions to develop and build in profitable energy storage projects in Brazil. So Brazil is a huge continent-side country, and we have those interconnect grid, which is very interesting, very important in this kind of size of the country. And as the Marco and Pedro mentioned before, there is a huge challenge and in the implementation of the new PV or aeolic or hydroelectric system. So we are really need to new systems. So basically, what we have in Brazil in terms of capacity and power, we have a very clean grid, and our grid is, if we look, so in terms of capacity, hydroelectric and is about 65%. This is not novelty for most of the listener here. 90% is aeolic, is like wind, and 1% solar. But all this number is very dynamic, and you see this changing a lot. In terms of power, solar is close to the second position, and wind as well. So very important. this electric matrix, the electric grid here in Brazil. So the evolution of the capacity installed here in Brazil is growing fast with lots of penetration, as the other speaker mentioned. So you see this, we did not combine this before. So if we are saying similar things, that's cool, because seems to be most probably reality. So the wind capacity is increasing a lot in Brazil, and the solar as well. So all of those systems are very interesting for the energy storage application, and that's I'm trying to explain a little bit better later on. As you see the grid here in the map on the left-hand side, there is a lots of parts on Brazil that there is no electric grid. So if we think in terms of the forest we have here in Amazon and Pantanal, for example, and also in huge farms where we produce and feed, produce food and feed about 10% or 20% of the population, depends on the statistic you look. There's a lot of spot here represented by this asterisk and on yellow, for example, just a very approximated position where the people have no possibility to have access to the grid. So in those parts, it's very important we have those isolated system the other panelists just mentioned before. So in Amazon and large farms, the diesel generation are replaced or also be combined with solar and battery solutions. So this small village we are mentioned could seem like a small proportion, but at the end of the day, if we integrate this, it's like a huge market and a lot of opportunity for installing this energy storage and the generation system like battery plus solar. Of course, we are not thinking about eliminate diesel, but sometimes to do the diesel arrived there is complicated and could work as a backup, but also like a complement to the solar and the battery system, as mentioned before. So Marco just mentioned we have some situations where on average, Brazilian person or people stay quite a few moments without the electricity, which is very bad. And I'm going to discuss a little bit better about that later on. But there's a lot of customers, not in the residential side, but on the industry, small business, market, shopping centers, where they're installing those batteries to have the reliability on the system, to keep the system running for longer. The opportunity are not really on the residential side, because we have like a volumetric tarific. I'm going to explain later on. But the point is that in high voltage system, there's quite a increase feeling here at the state of São Paulo, where I am right now, seeing a lot of people purchase and looking for battery solutions. Some different, as mentioned before, in the peak of the price of the peak, especially the peak where a lot of people go in the house or the industrial size. So the tariff is more expensive close to the night. So the price range quite a lot here in Brazil. As you see here, the price go for 0.9 reals by kilowatt hour to let's say the 14 most expensive one to 0.75 reals per kilowatt hour, which range immensely. So as I mentioned before, the business are not in residential part of the system. The small business and the house represent 50% of the electricity we use, but not that's not really the low voltage is not really the market, the business. I believe that we should have a look especially on the high voltage. Otherwise, the business doesn't stand by itself. So as mentioned before, the ancillary service, frequency regulations, there is a adjusting the generation balance, the spinning reserve, the capacity availability for emergency, the voltage control. There's quite a lot of important ancillary service in Brazil, which is about to be regulated to make it even more attractive. This kind of application for the energy storage system. It's very important to have this regulation as soon as possible, because otherwise, for example, hydroelectric bay usually work as a battery. Why we do not have much of a battery solution in this country is because we have a huge hydroelectric facility which work as a battery for a lung from the system. So other point is the wind production, especially in the northwest of Brazil, which we have a lot of potential, and we produce about 90% of the electricity here in this country, and the coast and the countryside as well. In the south, as we see here, some numbers just to make this more understandable for especially people from abroad. There's a lots of production here in the northwest and some on the south, Rio as well. But the main point is here, sometimes the grid could not receive electricity anymore, this renewable electricity. And there's a lots of projects, people thinking about using hydrogen production or battery to storage those electricity that being wasted. So one important point is that some misunderstanding is that, for example, in the blue line here, sorry, it's in Portuguese, but just to give you an idea, the blue line here says the hour of the day where we produce more electricity, especially on the coast. The coast here is the blue line, and the orange line is in the countryside, where they seems to be like they are matching together, but the production on the coast is much higher. So we still need a lot of infrastructure to this grid to use the electricity from the northwest to the south or the southwest, where we or the east, where we have some the most industry on this country. So about that, there's a lot of opportunity in off-grid, on on-grid system, where we could install this facility here in Brazil, where I put on some asterisk on yellow. So probably will be the next generation on the on-grid energy storage system will be in the northwest with wind. I don't believe that hydrogen will play an important role here, because it's too expensive. It's very hard to control the storage and the transport of hydrogen. You need to produce hydrogen and use as or produce ammonium at the same time. And to build all this facility, this pilot line or this industry, there's a huge cost involved. It doesn't make much sense not to use this 24 hours, 7 days a week. So the other point about a battery is the flexibility. So if we could, for example, install some battery and containerize this battery, we could move that from, like, say, this is today is profitable to do that here at São Paulo, let's say that, but tomorrow is not. We could just put this on a truck and move this to the other place, which we could not do this with thermal and the hydroelectric plants. And then this flexibility is very important. I know people from this market know this, but as we are discuss this to a wide audience, that's very important to say. And closing to the end, just to summarize, ancillary service will be very important to allow the power flow inverse to the solar, the voltage control, and the regulation on the frequency of the system as well. So battery will definitely play an important role in Brazil, and Brazil today have no industry, no battery, let's say the next generation of battery like lithium ion battery, like lithium iron phosphate. We still are lacking from a good service. We need to import almost of all the batteries we have from China, and we are seeing a lot of problems on some batteries we receive. We could not deliver back the post the sales, and the market is deteriorated, and there's a very important opportunity here to improve this quality. So that's very short. I'm Professor Hudson Zanin, and I'm research at the Center for Innovation on New Energies. I'm all the time on LinkedIn, so feel free to contact me. And this is the Center for Innovation on New Energy where we work, and we are funded by the Mover, the Hydrogen 2030 program in Brazil, and funded by Shell and the FAPESP as well. So thank you very much. Feel free to scan and shot me if you want to. Thank you.
Thank you very much, Hudson. And now we have Jocelino. Jocelino, whenever you're ready.
Hi, thank you, Elena. Hi, everyone. I'll just share my screen here. Okay, can you please confirm if you see my screen?
Yeah. Okay.
Okay, thank you. I'll talk a little bit, some cases, show some what's happening in the market in Brazil. We had a great presentation from my colleagues here, showing some off-grid systems, showing some opportunities, some areas. And as I mentioned in the introduction, we are working these several years. I'll show a little bit about what we are doing, what we are offering, what's more about, and then I'll show the case. Okay, just let me. Okay, so just a short slides about Moura. 66 years old company, Brazilian company, 100%. We have over 6,500 employees, 7 industrial power plants. We are the battery manufacturer leading company in South America. We have 7 industrial plants, 5 in Pernambuco, in northeast state of Brazil, 1 in São Paulo, and 1 in Argentina. This plant, we integrate the energy storage systems. We manufacture the lithium-ion batteries as well for several markets. We work at automotive market, traction batteries, many other markets, stationary batteries as well. We are all over the country with distributions and service units as well. We also, in the group, we had the Institute of Technology that is focused on energy storage solutions, both for electric mobility and also for energy storage systems. So he's working since 2012, 2013. We also make use of this institute to develop our solutions. This slide is important to show our portfolio for energy storage systems that we're talking about. Since the beginning, since before 2016, we are already developing the R&D projects in energy storage system. We developed the national engineering, so we are a made in Brazil company. Of course, we use the best technologies in the world to supply our solutions. Installation. We also have installation, operation, and maintenance services. Of course, Moura warranty, for who's in Brazil knows about Moura. Moura is synonym of quality, and also the reverse logistics is also something very interesting. We also supply that services as well. Jumping now to some cases that we'd like to show you some. My friend Marco showed a slide about energy storage system in Amazon region is near the Venezuela, Pacaraima and Amajari. It was the two first projects that, as a result of these off-grid systems, that supplied is an auction, right, to supply the cities that they're very far away from the grid connected. It's not feasible to bring the wire to there, and so this one, the first one who uh, who who's at who's the first two sites that supply with batteries, PV, and diesel. Okay. So this image is there are two cities, Pacaraima and Amajari. It's feeding over 30,000 residents in that region. Is uh, almost 6 megawatts of diesel thermal in distributing these two sites, almost 2 mega of PV, and 1.4 megawatt hour of energy storage. Mainly, this project is also, of course, avoiding to make avoiding to not use all the energy produced by the PV, so you store the energy to later. But the main important thing is to make it stable, because in off-grid systems you have a very different scenario from on-grid. Few companies operating this size of this, so you have the stability is very important. So is the batteries is um, uh, smoothing the PV production and also the variations of the load. Some results: 6.7 million liters of diesel avoided throughout the contract. Also avoiding 12,000 tons of emissions. Of course, there's also social impact associated with that. So this is a very interesting project that you can see for off-grid system, is the main reference now in Brazil. And more to come now, as you mentioned, more to come, because there is going to happen an off-grid auction for other cities. And now the energy ministry understood that this is a way. So the rule now for the next auctions is taking this as a standard, from this to more hybrid plant, not only thermal power plants anymore. So this is a good, very good impact of these projects here in Brazil. Also for electric mobility, we know that fast charge is a need for EV users all over the world, and Brazil has some issues to install many fast charges in parts of the city. And one solution developed by our R&D project with CPFL was integrated solution, all-in-one, PV plus BESS plus EV charge station. So it avoids uh, the need to increase the grid in that part of the network, and also to avoid, if installed behind the meter, avoid to increase costs of demand charges for the the consumer of energy. This other one is very interesting. Was the first one to water treatment plant in Brazil. Is a rental business model. So the water utility company didn't pay for this as investment. It was rented, and the money saved from peak tariffs is actually paying for this. And and we sharing the results with them. And what's happening is they had a big problem of quality of energy supply, and this we would depressurize the water pipes and make very maintenance problems. It would what was a big issue of maintenance, like leaking water everywhere because of the oscillation in energy. And now we solve this problem, and also saving some money from the for the peak period in Brazil. That usually 3 hours. I saw somebody commenting in here. So usually it's 3 hours. Someone talking about 5 hours discharge. So in Brazil is only 3 hours the peak tariff. so far, right? It might change. This is another for agribusiness model as well. So our PV and storage rental services. So we are avoiding like peak tariffs. Some parts of the country have weak grids, especially in the countryside, in agro, where we have a lot. So this one is operating as well. So it's the customer didn't make the investment and now is saving money from the peak period, and also solving some quality issues with power supply. So this the customer is very happy with this kind of application. That's a very interesting because as our friends showed about the huge size of the country, so taking grid for every part of the country is not good, is not easy, and sometimes there's a long line distribution line, so the grid is very weak there, and we need some support of PV plus batteries is a perfect solution for that. This is a very interesting project as well, also an R&D project in a 500 1000 kV, 500 kV substation for transmissions lines. Is actually is a from Eletrobras Group, Chess, the company. That's only one now. Is Eletrobras. Is a power source. Is an alternative power source to feed all the auxiliary systems of this substation. Has a big problems with power quality from the distribution to feed the auxiliary systems, and didn't want to put another diesel generator. So they were very innovative, and we made this project together to feed with two energy storage system, the Curiosity with lead carbon and another with lithium. It's an interesting project, R&D project that is running as well. This other one is very interesting. Some colleagues, Marco and showed some hybrid power plants. This one is, I showed you the off-grid power plant. This one is an on-grid, grid-connected power plant with wind, PV, and energy storage. There are two wind turbines of 1.5 megawatts. We are delivering the solar and the energy storage. Is under construction, but this picture is a little bit old. Is more advanced than that. You can see the left the building of the substation we made, and the roads and the PV is being built. And this one is studying the integration of that curves that was shown there between the PV generation, the wind generation, and the batteries to cope with that gaps that you have in generation for the electricity market, for the free market, for the commercialization, for the supply. So many things, many important outputs we're hoping to get from this project. Is the first one, I think, is the only one with at this size with wind, PV, and storage batteries as well. The battery is 1.5 megawatt hour. That's it that I would like to show to have some time for discussion and questions. We are running on time here, so thank you.
Thank you so much, Jocelino. We do have some questions here, and our first question is from Mariana Camara, which Pedro put it out that he would like to answer.
Okay, Elena, could you please show me the question again, just to
Sure.
be sure to point out all the things here.
Yeah. Is Brazil an open market that is willing to investigate it?
Yes. Okay, it's an open market that's willing to investigate it. For sure, Mariana, Brazil, actually, if you take a look, right after the beginning of our regulation development, in that slide that I showed, the timeline of our regulation development here, one of the first engagements of our national agency, Energy National Agency, was to engage in pilot projects to try several types of energy storage technologies and applications. if you want to engage in a specific project here in Brazil, I would recommend you to look for university groups like a Hudson group in Campinas. It's a strong group. And you can also look to my group, that is the Research Center for Greenhouse Gas Innovation. They are also sponsored by FAPESP, Shell, and other oil and gas companies. And they are engaged in different kinds of developments for energy storage and related subjects for the low carbon economy, okay? Brazil has a very good portfolio of universities and labs all around the country. And I think the right way to come to Brazil and try to develop a new business or implementation would be through a Brazilian technological partner. And I would look for our universities. And I think you would have let's say a better way to achieve the right information that would impact in your development. You see, in terms of legislation, regulation, specificities of the Brazilian market, it's important for you to be partnering with a Brazilian technological partner. Look for university groups. If you want to talk to research center, you can talk with me, RCGI. I would be very glad to have a discussion with you, okay? Also, is Brazil ready for long storage duration greater than 5 years? And how quickly is the country ready for this growth? Yes, southern Brazil would be ready, okay? Actually, we have a seasonal characteristic of our electric matrix. So if you're talking about hours, right? But if you take a look on how the electricity matrix the Brazilian electricity matrix operates, it's very seasonal, and now we have those variations of daily load on the grid, and any kind of reserve capacity that's okay, not so much, and any kind of reserve capacity that would be interest for us to develop, okay? Third, the capacity market, the government has a role to implement this in materials and profile. Basically today, I will say about the spinning reserve, okay? Our spinning reserve is based on thermal power, thermal gas power plants, around 8% of our capacity, and mostly coming from hydroelectrics. The problem is that the hydroelectrics are already facing some challenge to disposal all their capacity due to the high volumes of water that are needed to increase the loads at the patterns that we need. You see, so we need the market capacity is good now. And I'm sure that our agency, our national agency, electricity agency, would be interested to study different kind of applications and possibly to implement a pilot project and test it fits with the Brazilian matrix, okay, electricity matrix. I don't know if I answered your question the way you would like. If you want need any more detailed information, you can send me by LinkedIn or email. Okay. Elena, there is another. Okay.
Go ahead.
And also, Roche asked to present comparison figure for the storage technology with a book reference do not fit with other international shots I have seen, especially the representative rate, the chemical battery seems. This chart, Nelson, was presented by a magazine, a German magazine, specialized magazine, and it's a very, very high, very well structured magazine. I would suggest you to take a look. I can put here the reference, but it's very complete. It's a very, very huge book. Okay.
Thank you, Pedro. We do have another question from Nelson Rocha to Hudson. Hudson, would you like to give it an answer?
Oh, yeah, thank you. Please comment about the possibility to use BESS to replace peak power diesel generation in urban areas, which operate daily at the peak times. Oh, yeah. Today, as I mentioned before, we have already the possibility to put on place a BESS that is competitive in terms of cost to the diesel generation. But as we price, and we saw some price that Michael, for example, present here today, I guess was Michael's or Pedro, I don't remember, but relate to the cost on dollar per kilowatt hour produced by a battery. And when I mentioned that the market is deteriorated, is that because sometimes you purchase a cell from a company which says that it's going to cycle like 4,000 cycles, which could be more than 20 years. At the end of the day, with the climb, the not appropriate conditioning or the cell problem on the manufacturing, the cells is running much less than that, like a quarter of this, like 20 or 1,000 cycle, for example. And that's the price of the battery should be put on place, like a dollar per kilowatt hour per cycle. And that's the most important number we should have on mind, because change everything. So because it's a new technology and the Brazilian have a lot of other possibility, like using hydroelectric is much cheaper than using battery. But as you mentioned, at where you could not use, like in the peak, battery will be replacing the diesel generation as people get more confident, as the market be more regulated, as we find a way like buying metal or other possibilities here to make sure the confiability of the system and the conformability as well are nicely and properly done. And there's another question I tried to answer here for someone else, and I guess I erased it, and so I'm sorry. Someone asked if what happened with the battery in Brazil, as if it's how we dispose this battery in Brazil. We don't have much volume at the moment. We have on those cigarettes, those e-cigarettes, and the truth is that those batteries go to the bin, which is a shame. This is very dangerous and cause some trouble to the environmental. But huge batteries from car batteries, bus batteries, is still in an initial movement, and there is no much volume. So we do not know in Brazil who is the owner of those battery. At the moment, this battery is stay locked in some place, in some facility and some storage place, and it stay there. People are looking for second life batteries, and we still have no, still not sure if this battery is safe. We have bankability to make sure we could put like a second life battery for more 10 years. And this is still very initiative in Brazil, but huge batteries is just locked in at the moment, and some recycling are taking place. We have the technology, we have the know-how, but we do not have the volume to recycling. We're recycling aluminum can from beer or some, I don't know, some Coca-Cola, for example, but we do not do this with battery. We do not recycling because we are still in the beginning of the process. So that's it. Thank you.
So much, Hudson. I'm going to copy paste the question that we have received for Jocelino to answer. but it's not on the question and answer. Go ahead, Jocelino.
Yes. Hi. Yeah. Sorry, I just clicked on to answer live, and it was to the answered box here. But there was anonymous. But do you do only battery integration in your factories, or do you also manufacture battery cells? We work with two technologies. Okay, lead carbon and lithium ion. Lithium ion, we do not manufacture cells. We integrate cells into batteries and supply to the market for storage systems, for electric trucks, for forklifts, for solar. We have many markets that we attend. So that facility that I showed the picture, we manufacture the batteries there, not the cell. But for the lead carbon battery, we make everything, until the plastic, the iron box, everything we manufacture, and we recycle everything as well. For 1 ton we sell, 100,000 tons we sell, we recycle 100,000 tons of lead carbon batteries. For the lithium we are working on, we gave a proper destination, but we are working on, we're building a huge recycling plant here for all technologies.
Thank you so much, Jocelino. Well, I think that we are running out of time, so I want to appreciate all your time that you had today in joining us to this webinar. Thank you so much. I hope to see more webinars soon. Thank you.
Thank you.
Goodbye.
Thank you, Anana. Bye-bye.
Thank you, guys.